Hey guys! Welcome back to the laboratory. In this video, we are looking at distance time graphs. By the end of this video, you should be able to identify the use of distance time graphs, draw and interpret distance time graphs, and calculate speed using distance time graphs. So, let's go. The speed of an object is a measure of how quickly it travels a particular distance. We can use distance time graphs to provide a visual representation of the time taken for an object to cover a certain distance. Let's look at this distance time graph as an example. At point A, we have an upward sloping straight line. On a distance time graph, this line indicates two things. The first is that the object is moving away from its starting point. We can confirm this by looking at the values along the x and y axis of this graph. As the line slopes, we see that the distance of the object is increasing from 0. The second is that the object is moving at a constant speed. This is reflected by the straight line. At point B, we have a horizontal line. A horizontal line on a distance time graph indicates that the object is stationary. Once again, we can confirm this by looking at the values along the x and y axis. Although time is passing, the distance travelled by the object has not changed. Therefore, it must be at a standstill. At point C, we have another upward sloping straight line. Much like at point A, this line indicates that the object has continued to move away from its starting point at a constant speed. However, at this point in the journey, the object is moving much faster than it was at point A. We can identify this by looking at the steepness of the line. The steeper the line on a distance time graph, the quicker the object is travelling. Finally, at point D, we have a downward sloping straight line. A straight line still indicates that the object is moving at a constant speed, but the downward slope of the line indicates that the object is returning to its starting point. We can confirm this by looking at the values along the x and y axis, where we can now see that the distance travelled by the object is decreasing. We can use the gradient of a line on a distance time graph to calculate the speed of the object at different parts of its journey. To achieve this, we would use the equation linking distance, speed, and time, where speed is equal to the distance travelled divided by the time taken. For example, let's say we wanted to calculate the speed of the object at point A in the journey. The gradient of the line at this point in the journey is equal to 10 meters minus 0 meters divided by 20 seconds minus 0 seconds. This means that the speed of the object at point A is equal to 10 meters divided by 20 seconds, which gives a total of 0.5 meters per second. Let's look at another example. This time, let's calculate the speed of the object at point C in the journey. The gradient of the line at point C is equal to 40 meters minus 10 meters divided by 60 seconds minus 40 seconds. This means that the speed of the object at this point in the journey is equal to 30 meters divided by 20 seconds, which gives a total of 1.5 meters per second. Calculating the speed at this part of the journey also helps us to prove that a steeper line indicates a faster moving object, as our calculation for speed at point C in the journey is higher than our calculation for speed at point A. Now it's your turn to test your understanding of distance time graphs. Pause the video and identify which of these three statements correctly describes the distance time graph provided. Press play once you're ready to check your answer. The only correct answer for this question is statement 1. The first upward sloping line on this graph shows that the object has travelled 8 meters away from its starting point. This is then followed by a horizontal line, which indicates that the object is stationary. We then see a downward sloping line, which indicates the object is returning to its starting point. However, the line stops at 2 meters and does not meet the x-axis. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!